Morning, students. So today class we are going to see about the uh, uses of GPS, GIS, and mapping software in the precision agriculture. So GPS is the geopositioning system, and GIS is a geological information system. So which has been used for the precision agriculture process. So first of all, GIS and mapping softwares, so which are used for the spatial data analysis and visualization. It also creates maps and quantification of uncertain values, and it supports the geostatistical methods for mapping the sparse data, and it is widely available for the precision farmers and their advisors. So these are the common uses of the GIS mapping software. So GIS is used for the geological information regarding the terrain or land area or agriculture area. So that has been replaced for the precision agriculture process. And GPS. So GPS which provides a location data to spatial analysis and mapping. Which enables precise measurement of soil properties and also crop yields, and supports variable rate application of fertilizers and other inputs. So, yeah, GPS should be used properly in the field of precision agriculture because in precision agriculture most of the systems are automated. And automated needs the perfect location and the proper location, which should be in the automated system should be carried out, and the data of the terrain also should be known properly. That provides a detailed mapping for the crop monitoring and for the automation, automated vehicle travel path. So that there are many purposes we can use for that. This GPS and GS. Now we can see about the what are the uses of the GPS and GS and mapping softwares in the precision agriculture. So by utilizing the GPS and GS in the precision agriculture process, so we can efficiently manage the farm. Okay, so we can understand what type of land it is there and what are the activities should be prepared for the land, and you can understand the nature of the land, that is terrain nature. Okay, so how it is the moisture content present in the soil, or it is very rough terrain, and whether there is maximum wastages are available on that land. Like that, we can understand the land surface, and we can do the particular action. We can efficiently replace the farm management process, and from that we can uh, make our management decisions on the nutrition of the soil, and nature of the soil type, and the weather conditions also we can observe, and we can understand also the crop response to the fertilizer using the field trials and mathematical models. So we can understand we can monitor the crop growth periodically by using the remote sensing softwares, and we can map the growth of the crops periodically. So from that we can understand so what is the healthier crop is grown there, and whether there is any unhealthy crop is there, and we have to concentrate more on that area, and we can improve the yield, and we can minimize the waste also. And the knowledge of the spatial variation within the fields from experience and instruments for sensors. Okay, so this can be observed from the spatial variation within the fields. So one side is a better farming place can be having a better growth area, and another can be understand on the spatial variation. Okay, then geostatistical methods for the mapping from sparse data. Okay, then unbiased interpolated values with minimum variance and estimation of variance for uncertainty. So these are the uses of the GPS and GS in the precision agriculture process. Uh, the limitation, meanwhile, the uses are there. There are some limitations are there. We cannot completely trust on the GPS and GS data. Then it may sometimes may cause some errors also. When default methods may be unsuitable for uncertain in certain circumstances. Then the limitations of particular application skills due to technology can be affect that yield also. In some cases has been observed, and changing the support of the configuration properties and more problematic solutions are still not existed. These are the limitations of the precision agriculture, and the technical enhancements in GPS and GIS are the kinematic GPS, so which is a provides a more accuracy than the sibling GPS what we are using in our mobile phones and gadgets what we are there, and phase shift smoothing for the improved position resolution. Then real-time kinetic GPS for the high resolution dynamic position. For high resolution dynamic positioning, we can use for the real-time kinetic GPS, and integrated of navigation systems for reliable and robust positioning. So this navigation systems provide us a more robust positioning, which in case need the precision handling of the uh, agriculture crops. That is, for example, for sowing the seeds, removing the weeds, fertilizer research like that we can use. So in that aspect, the future directions are visual based navigation with GPS is possible, and the precision application at the individual plant level. We can individual plant level the precision application variation can be seen and improved reliability and accuracy of dynamic positioning for the traceability and targeting of the crops. So now in that aspect, we are going to see the different types of GPS. And first one we are going to see is carrier based GPS. So simply it is called CPGPS. It is a high precision GPS technique used for precise positioning and navigation. So carrier based GPS for horizontal phase of business, carrier based measurements instead of using pseudo range instruments. CPGPS uses the phase of the GPS signal carriers where to determine the position. And second principle is integer ambiguity resolution. The carrier phase measurements are used to resolve integer ambiguities, which enables the precision positioning. Okay, so these are the two principles of carrier phase GPS. And advantages of carrier GPS is high accuracy. So it provides an accuracy of up to 10 centimeter positioning accuracy. So nearly accurate positioning. And the precision of this positioning also very accurate. That is 1 to 10 amount. The precision is there. Then uh, it is a real-time kinetic positioning. Yeah. So while in the movement, it will also provide a real-time positioning and long range accuracy. Yeah, the maintains accuracy over a long distance. At a long distance, we can provide the positioning also. Applications of the carrier with GPS. In general, precision agriculture is the surveying, aviation, maritime, robotics. So, what are the key components involved in the carrier with GPS? GPS one, GPS receiver, which is used for measuring the carrier phase, and second one is antenna, high quality antenna for a signal receiving, and a base station. Yeah. So, for understanding the questions, the reference station is needed. There is a base station, and software processing and analysis of the software for the integer ambiguity resolution. The resolution of the question is based on the software used. So, these are the key components used in the carrier phase GPS. So the challenges in the characteristic is multiple problems, atmospheric winds, satellite transmitting, and ambient solution. These are the challenges faced in the providing the accuracy variation of the sea character GPS. So in this, various techniques are used for providing the accurate positioning. So that is one is a real-time kinetic positioning, RTK positioning, that is precision point positioning, that is PPP, and differential GPS, then wide area augmentation system. So these are the various techniques used in the carrier GPS. And future developments in CPGPS is increases satellite constellations, improved signal structures, advanced receiver technologies, integration with other sensors. So these are the future developments has been shown in the carrier-based GPS. So what are the applications of the carrier-based GPS in the precision agriculture? One is automated stage, yeah. So which enables the accurate and precise automated steering for tractors and reducing overlap and skips. And the second is crop monitoring, high accuracy positioning for crop health monitoring, yield mapping, and precision application. And third one is variable rate application guides, which CPGPS guides precise application of fertilizers, pesticides, and seeds. And fourth one is autonomous farming, enables autonomous tractors, drones, and other farm equipment. And precision aggregation means the water application based on soil moisture and crop water stress. The benefits of the carrier-based is increased efficiency, reduced overlap, and skips and optimized application. And accuracy, improved accuracy, that is 1 to 10 centimeter precision accuracy, and enhanced crop yields, and reduced waste and cost savings. These are the benefits of the carrier-based GPS in the precision agriculture process. And the key components already we have shown. That is GPS receiver, antenna, base station, and software and integration. Challenges are involved in the precision agriculture, signal interference, infrastructure, cost, and training. So these are the challenges as faced in the precision agriculture implementing the CPGPS. Future developments, the integration with data sensors, improved signal structures, increased satellite farming, autonomous farming advancements, artificial intelligence, and machine learning applications. So a case study has been understand has been shown here for the in case of using the carrier-based GPS in the precision agriculture process. 1,000 acre corn farm in Iowa State of USA has been implemented the carrier-based GPS process to improve the efficiency and reduce the waste. The carrier-based GPS system installed for the tractor for automated table and variable rate application. So from this, after uh, and before the implementation of the Scarify GP system has been, the research has been analyzed, and research showed that the 10% increase in the profits, the productivity has increased to the 10%, and 15% of fertilizer usage has been minimized. 20% of reduction in fuel consumption also achieved from the after implementation of the Scarify GP system, and also they have finally summarized that the improved accuracy and efficiency has been uh, achieved after using a carrier-based GPS system. So these are the various company GPS systems has been listed over here. There is uh, various implemented systems of carrier-based GPS has been given over here, and how the process taken place. The various case studies has been the reference pictures has been depicted over here. And, this is a farm wise. This is using carrier-based GPS for full and full autonomous farming process. So from GPS, how the autonomous farming process has been carried out has been uh, the research is going on, and they have been completely the farm wise has been developed a machine with the help of the carrier-based GPS equipment. So that's all for today class. Thank you.